GitHub Actions are so cool. You can automate your workflow for free and they're really easy to set up. However, since the actions run on GitHub, every time you want to change something you need to commit and push to your repository. For example, if you're fixing a failing build for an unexpected reason, it might take quite a few frustrating cycles of code, commit, push and repeat. But we are programmers, we're lazy, and someone already found a solution for this. Act is a command line interface that lets you run your GitHub action locally in your computer, without the need of pushing your commits to GitHub. Actually, you don't even need commits. Some key features, well, it's user-friendly. After the initial setup, all you need to do is running Act in your terminal. It's written in Go, and it's open source. Head over the GitHub repository if you want to contribute. Sounds great, but how do I get started? Well, good question. First of all, since Act runs with Docker, make sure to have it in your machine. If not, just head over the Docker website and install Docker Desktop for your OS. Back to Act, if you're using Homebrew for Linux and macOS, brew install Act will be enough. If you want to use a different method, the README of the project has a long list of options. Once the installation is done, run Act in your terminal to give it the first time configuration. In case you get an error similar to this one, don't forget that Docker has to be up and running while using Act. So, launch Docker Desktop and run again Act in your terminal, and the first operation will be pulling the Docker images. Wait, is it actually doing anything? Well, yeah, it is downloading Docker images and it might take some time, so sit down and relax as the download continues. Anyway, running Act with the argument --verbose will reveal the truth. And now, well, let's keep waiting. By the way, while the download is running, make sure to subscribe to my channel because I usually talk about open source, so you might be interested in videos similar to this one. Demo time! Now that we have everything set up, let me use this simple project with 3 workflow to show you what Act can do in action. First of all, we have this hello.yaml that is a simple workflow with 2 jobs. It will say hello in the console and will say hi in the console. The second job we have is test. This is a simple unit test job that will basically do checkout of your repository, set up node, install dependencies and finally run npm test. The test is just a simple test over here, just for the demo purpose, and the definition of the command is here in the script on package.json. Nothing too weird. And then we have the super secret file that we'll see later. To begin with, let's try to do something with hello. So, we can open the console, run act.l that will print the list of the existing jobs we can run. As you can see here, hello world is listed twice because we have 2 different jobs in this file. That is say hello and say hi. And then we have the other jobs on top secret and test. There's also this warning over here that tells that since I'm using an Apple M1 chip, it says I should also use this argument over here every single time I run a command. For example, act.l and I can paste this command. And the warning is gone. But since it is annoying to have to do that every single time, you can add it in the global config file where you can define all commands arguments that are passed every time you run a command. The file is in the root folder and you can find it with the name .actrc. So if I just paste this line over here and I try again to run the command without explicitly setting the flag, the warning is gone, because every time I run act, all those arguments are passed to the console. Now, let's get back to the hello.yaml. Let's say I want to run the first job. I can type act.j and type the job ID, for example, say hello. This will bootstrap a Docker container and will execute everything that is inside the job. In this case, I'm just echoing hello world and running. Same thing, if I type hello hi, it will run the other job that is shown here. Now, let's get a little bit more complicated and try with the test job. As we just said, we will do the checkout, install node, CI, and finally test. So let's give it a try. act.j test. This is the ID of our job. Now, what is going on here? It did the checkout of the repository and now it is installing node because we defined the version being 16.18. This will also bootstrap a Docker container where the version of node will be installed and action is run. Now it successfully ran npm CI, so we add the dependencies, and the next step will be running npm test. Okay, and there it is. It took a few seconds, but npm CI was complete. And now, this is correct, this is the test. And there it is. Okay, one test passed because it was our test. And everything is completed and the Docker container has been destroyed. If I run it again, and I also open Docker Desktop, you will see this container that is running right now. That is exactly the container where our action is taking place. As soon as the action will be complete, this will just disappear. Let's see what happens. It is running the tests are completed, and boom, the container disappeared. Now, if you want to keep the container, because for example it might be faster in subsequent runs, if for example you're trying to test in something that is longer, you can add the R parameter that is reuse, and in this specific case, the container that is created will remain even if the action is completed. For example, if I cancel it mid-job, you can see that the container is still here up and running. And if I run the job again, it will not create a new container because our container is still there. And that's why it should be faster every time you want to run the same action. When you're done, you can manually delete the container. Now, let's stop the console and move to the secrets workflow. Here, as you can see, it will just print two variables, but this time the variables are coming from the environment and from the secrets. The environment is usually the .env file that should be on gitignore, but for the purpose of this demo it is not, and has a number. There's also a secret that is basically what you should feed from the GitHub settings, and this is needed to run secrets, for example your GH token, or if you have API keys for external services, and those values must not be known by anyone. Let's see what happens if I try to print the environment and the secret. act-j top secret, that is the ID of the job, and again it created the container, and what happened here? My m value is 42, this is correct, but my secret is... it didn't show our secret, that is not these 3 asterisks, because the secret is actually... you'll never know. The reason is quite simple. GitHub Actions are smart enough to not let you print in the console your secrets, because as the name says, they're secret. So how can we know if our action correctly picked up this secret? We can go back to the action, try to feed an invalid name here, and run the action again. What happens is that the value 42 is still fine because it's from the end, and the secret is empty. It's empty because it couldn't find the secret, as simple as that. So if we feed back the exact value, the correct one, there it is. So now we know that our GitHub action successfully ran reading the value from env, reading the secret, and using it in the pipeline. With those simple steps, we have basically everything we need to test even more complex action. And in case you want to learn more about Act, as usual you can find the help command that will list all commands available, and there's also a lot of documentation in the GitHub page. Simply amazing! You no longer need to commit and push every time you want to test a pipeline, but you can do it locally with Act. Now, you finally fixed your pipeline, and you might want to open a pull request so that it can be merged. But how are you gonna close your pull request? With a merge commit? With a squash? With a rebase? Let me show you the differences here.